All right, let's get right into it. Today, we're popping the hood on the human body to figure out what's really going on with our energy. We're going to look at the 3 hidden engines that power every single move you make, from an explosive jump to a marathon. So, how does it all work? Let's find out.
You know that feeling, right? You're going all out, absolutely flying, and then, bam, the tank is just empty. You hit a wall and it feels like you hit it at 100 miles an hour. So what's actually going on inside your body that puts on the brakes so hard?
And then there's the burn. Oh, that deep, fiery sensation in your muscles. For years, we've all pointed the finger at one single culprit for that feeling. But what if I told you that whole story? Well, it's not exactly true.
I mean, think about it. An hour-long jog and a single explosive jump feel like they're from different planets. And it turns out the way your body fuels them is completely different too. Understanding this is honestly the key to smarter training. So let's get into the nitty-gritty of your body's amazing energy systems.
Okay, so before we can even talk about the different engines, we have to talk about the one type of fuel that they all use. You can think of it as the spark plug that ignites every single muscle fiber in your body.
So say hello to ATP, which stands for adenosine triphosphates. This little molecule is the only thing your muscles can directly use for energy. And that cash analogy? It's perfect. This isn't a check you gotta go deposit, it's cash in your hand, ready to be spent this exact second.
So how does it work? It's actually super simple and elegant. ATP, right, it has 3 of these things called phosphate groups. When your body needs energy, an enzyme comes along, snaps off one of those phosphates, and boom, a burst of energy is released that makes your muscle contract. What's left over is something called ADP, with just 2 phosphates.
But, and this is a huge but, there's a catch. Your muscles only store enough of this ready-to-go ATP for about, 4 seconds of all-out work. That's it. So to keep doing literally anything, your body has to have a way to make more ATP, and fast. And this is where our 3 engines come into play.
All right, let's talk about engine number 1. Think of this as your body's rocket booster. This is for pure, raw, explosive power. We're talking right here, right now.
This system is unbelievably powerful, but it's also gone in a flash. We're talking 10, maybe 15 seconds max. And after that, the rocket fuel is completely spent.
This is your ATP PCR system. The PCR stands for phosphocreatine. It's anaerobic, which just means it works without oxygen. It uses that phosphocreatine to instantly slap a new phosphate back onto that leftover ADP, making fresh ATP on the spot. It is the absolute king for anything that needs a massive, immediate burst of power, like a 100-meter dash or a super heavy deadlift.
Okay, so what happens when that 15-second rocket booster just fizzles out? Well, you don't just collapse. Instead, your body seamlessly kicks it into its second gear. This is the engine for high-intensity stuff that needs to last just a little bit longer.
This next system, this one can keep you powering through at a really high effort for up to about 3 minutes. So think about something like a brutal 400-meter sprint, or maybe a really intense rally in tennis that just won't end.
We call this the glycolytic system. Now, just like our rocket booster, it's also anaerobic. No oxygen required. It works by breaking down carbohydrates, glucose and glycogen, really fast to make more ATP. But this speedy oxygen-free process creates a very famous byproduct that I'm sure you've heard of, lactic acid.
Yeah, for decades, lactic acid has been the villain. It's the bad guy that makes your muscles burn and forces you to slow down. But modern science has completely flipped that idea on its head. It turns out our bodies are way smarter than we gave them credit for.
So check this out. It's called the lactate shuttle. That stuff isn't just waste. It's actually a valuable source of fuel. Your body shuttles it over to other places, like your heart or your liver, where it gets converted back into glucose for more energy. So then what causes the burn? It's not the lactate, but the buildup of hydrogen ions that are created right alongside it. The lactate is just kind of guilty by association.
Okay, so after about 3 minutes of going hard, your body knows it can't keep that pace up. It needs a more efficient, more sustainable way to make energy. And that's when it's time to switch on the third and final engine, your long-distance cruise control.
This system is the master of any sustained activity. Seriously, if you're exercising for more than a few minutes, this is the engine that's doing almost all of the heavy lifting.
And this slide right here shows you why. Just look at the size of our fuel tanks.
Our carbohydrate tank is pretty small, right? But look at the fat reserves. It is a massive, almost bottomless pit of fuel that this cruise control engine is perfectly designed to tap into.
This is the oxidative system, and as the name implies, it needs oxygen. That's why we call it aerobic. It can burn both carbs and fats to produce huge amounts of ATP, just at a slower pace. It's not as powerful as the first two, but man, it can go for hours and hours. It's like a super efficient hybrid car, just built for the long haul. This is the undisputed engine of endurance.
So we've got the rocket booster, the passing gear, and the cruise control. But honestly, the coolest part isn't what they do by themselves, it's how they all work together. See, they aren't like light switches that are just on or off. They're more like dimmer switches, constantly sliding up and down to perfectly meet the energy demands of whatever you're doing.
And this chart really puts it all into perspective. A golf swing? That's almost 100% rocket booster. A game of basketball? It's a crazy mix of all three. You've got explosive jumps, repeated sprints, and then jogging back on defense. And of course, distance running is dominated by that aerobic cruise control. Every single sport has its own unique energy fingerprint.
So here's the big takeaway. It's never ever just one engine working alone. Your body is this incredible machine that is constantly seamlessly blending these energy pathways to give you exactly what you need when you need it. And understanding that blend is the foundation of really smart, effective training. And that really brings us to the final question. For you, every time you work out, you're not just working your muscles, you're conditioning these energy systems. Short, intense intervals train your first two engines, long, slow runs build up that cruise control. So now that you know what's under the hood, what are you going to train next?